Hello, everyone, dear students. Welcome to Introduction Geography Information course. So today I'm going to explain you how to delineate watersheds using DAM. DAM is a digital elevation model. The first of all, you have to go to View Catalog Pane and upload your DAM. This is your DAM data. This is the DEM data. It's black and white. The white area shows the very high elevation points, and the black points shows the low elevation points. Okay, but black and white difficult to analyze by visual, so that's why we have to change the color symbology. I press the color scheme and show names. This is the elevation data, so I have to search elevation. So this is the elevation. I select this one. Now I close this window. Now this digital elevation model means something to you. Okay. The pixel size is 30 meter to 30 meters. You can see this by properties, source, and raster informations. The pixel size is the 70 centimeters, 85 27 meters, more than 27 meters. Okay, it's projected um, UTM coordinates. The ellipsoid is Vega 84, and UTM projection zone 42N. Okay, so I also upload my area of interest. This is the vector file. Um, I change the color and give the outline color. Maybe 2 is better. Okay, so my area of interest is inside of this the boundary. Okay, this is the vector polygon file, so I have to extract this, only this area, by using the extract by mask. So I go to analysis tools, and in geoprocessing tab I have to write extract by mask. It's a Russian, so I have to change extract by mask. Okay, now you can see the extract by mask, the functions. So input raster, I have to select my DEM file, and input raster or feature mask data is of course the boundary. So other parameters is we can keep the default, but only output raster I have to give the name of output raster. This is the like, let's say DEM boundary. Okay, this is the inside. Of course we need the inside of the boundary. We run. It takes some time. So now we have a raster file. So I turn off the big raster file for the moment, and I again change the symbology. This elevation 1 is here. Okay, so this is the my area of interest. Then the first step is I have to do the fill fill. I have to select this dam boundary and the results of the dam fill dam will be fill dam boundary. Okay, so I will compare the digital elevation model of the boundary and the fill dam boundary. You see the value, they didn't change. That means in my dam boundary there is no null data or think data. This is good. So I turn off the dam boundary, and from now I will use fill dam boundary. Okay, again the symbology, I repeat the same thing. This is the elevations. Okay, the first step, I have to calculate flow directions, flow direction map by using this one. So tools again, flow directions. This is the flow direction spatial analysis toolset. So input survey raster is of course fill dam boundary. You can select the fill dam boundary from here, or you can just take dropping down here. Okay, the output file is flow directions. Let's write dam. Okay, or maybe we can. So this is the input dam, fill dam boundary, and output will be flow direction dam boundary. Okay, and this is the flow direction tab is D8. There are different formats, but we select D8. D8 is the directions. We have 8 directions. Each direction they have a specific value. Okay, so now let's run. This is my flow direction. Dam boundary is ready. So next step is we have to calculate flow accumulation data. Okay, again analysis tools. We have to write here flow accumulation data. Flow accumulation. Select input flow direction raster. Of course, we have this file we just calculated, and our output accumulation raster. Flow accumulation. I have to change the name a little bit. Flow accumulations. Then boundary. Okay. There, it will be flow data. Run. Run. So now my flow accumulation data is ready, but you see it's very hardly we can see only one channels. Okay, that means we have to change the classifications. So I open the symbology again in stretch classifier, but I have to select classification classes 2. Right? And now still we have only one channel. Okay, to see the more channels we have to increase this value, because it's almost all the small channels is uh, inside of the yellow, so we have to change. So we can go to histogram. You see, if I increase this, if I decrease these yellow portions but increase the red, that means we have this screen will show more river networks. You see, here is this streams is up here. So again, you see the more, but I can, you can change this value by double click. Maybe let's write 20,000. Okay, okay, 20,000. If I do the 20,000, you can I can see more channels. Please keep in mind this value 20,000. Actually, you can decrease more, but I satisfy with this image. Okay. So next step is I have to extract raster value which is higher than 20,000. Okay, and this will be the red, this part. Okay, and this will give me the river stream network raster. So I use the raster tools, raster calculator. Raster calculator. So I have to use, I can use the condition functions. Here is the conditions because I'm extracting the modem higher than 20,000 pixel value. So the conditions, I will select this flow accumulation boundary. This is the this file. Double click, and then uh, after I have to select higher function, this one, and I have to write 20,000. Okay, maybe you can ask the question where 20,000 came from, because as you already seen that I changed the histogram and selected 20,000, and 20,000 give me better stream network data. Okay, 20,000 and comma 1 and 0. Okay, so that means this expression means the function will extract me the pixel value which is higher than 20,000 and indicate these 1 and less 0. So that means the resulted file will be in a Boolean format. Okay, 1 and 0. So this is the I can give the name river network. Okay, okay, run. I hope it works. Okay, yes, perfect. So this is the Boolean format raster. 1 means pixel higher than 20,000. 0 means is a lower. Okay, then I can symbology, and I can remove the 0. Okay, and turn off the flow accumulation boundary and also flow direction boundary to see the network. Okay, this is the, you see the results is not bad. Okay, to calculate total river network, you have to convert this um, raster to vector. Again, we go to tools, toolboxes, the conversions from raster to polyline. Okay, input raster is this one, and field value, and output polyline feature is you have to give the name again. um, River network, but this time I can add maybe vector is better. Okay, run again. I just converted my raster raster file to vector. Okay, I turn off the raster, but this is now vector file. Okay, the vector file is a better thing that you can change the width. Double click, and this is the width. Please apply. You see, I can change the color to blue. Um, okay, perfect. Okay. To see the total lengths, I can open the attributes. This is the shape lengths. The shape lengths of the each streams. So I have here 280 individual streams. Okay, and these streams, individual streams, this is the length of each stream. So if I want to see the total length, I just do the statistics. And this here the statistical table, but the sum, okay, the sum is this. See the total stream length. This is in kilometer 960 more than 963,000 kilometer total length. I close the statistics. Yeah, perfect. Okay, so each stream, for example, each stream has its watersheds, okay, or basin. So what is the watershed? Watershed is the area of land that catch the water. They catch the water, and it's distribute discharge is from the outlet point. So point this point will be outlet for this watershed. Okay, and these points will be the outlet point, or this point will be outlet for this the big watershed. Okay, and two sub watershed makes the bigger watersheds. Okay, for example, here is also one outlet point. This is also the outlet point for this watershed. So now we have to create one point which indicate as the pour point of the watershed. So view catalog pane. Inside the DEM I have to create shape file, or I can use this my already created PowerPoint. So okay, and this is the here. Okay, this is the here. If I turn on the river network, so this pixel is, for example, show the outlet points. Okay, So now everything is ready to identify the area of this watershed. This watershed pour point is this, so I will activate watershed function. So it's asking me D8 flow direction raster. Here it is. Here it is. This must be calculated. And pour point data. This will be your pour point data. Okay. This is the watershed boundary. Okay, now run. So the area of watershed is really this area. Okay, the outlet point is here, but it's still, you can see it's still raster format, but I need a vector format. So I convert this raster to vector tools, conversion to, but this time we have to select the polygons. Okay, raster to polygons, because this is the polygon. Input raster is this one, and value. Okay, but again I have to change the name. Just watershed. Let's say it, just watershed. Okay, now this is my area of watershed. So I turn off this, double click, no color, but this is the red. Increase the boundary, apply. Okay, here it is, the boundary. If you see, the boundary is delineated at most high point elevations, the white. Okay, I can see the same information in 3D formats, but this is better, you understand better mean of the watershed. So insert new local sand. Takes some time. Okay, but I have to, this is the sand, but I have to copy my watershed boundary, this file, the vector file, um, copy, go to sand, paste. Okay, now look, and also I have to also copy the pour point to sand, paste. And this here, I can increase it little bit, size. What color is the apply? Now this file, and also I can copy the river network, copy to send. Okay, but you see, I think that 20,000 is still enough, not enough, because here is some channels. You can see these channels, tributary channels. So it's better maybe 10,000 or 5,000 of the condition is better, because here is only one rivers. Okay, never mind. So you can also upload to this digital elevation model to the same that's here. Okay, copy, send again, paste. Okay, but you see, you cannot see the river network and watershed because this is the upper. And maybe now you can see. Yes, perfect. Okay, that's now I can see the dam. Now it's a dam. This is the dam. Okay, this is the digital watershed area of this stream. So here, all the water which is catch this watershed is collected and distributed to this river, and this is the outlet point. Okay, I hope now you understand. Um, I can remove this field, and also I can you can use this topographic view. Okay, very beautiful, very beautiful. So you can also upload the as a base base map, imagery like Google. Perfect. Now you see this is the watershed area, and this is the pour points. Maybe yellow is better, I think. Perfect. Yellow. And also I can increase the width to maybe 4. Okay, now it's perfect. So we've finished. The only thing you have to calculate the area of the watershed. You can do it in the scene thin, and area of watershed is this one. Okay, but this is the meter square. You have to convert it to kilometer square. To create this kilometer square, you have to delete it to 1 millions. Okay,